Have you ever stopped to think about what's really going on when you click a link or when you save a file to the cloud? I mean, it really does feel like magic, doesn't it? But it's not magic. It's all powered by this incredible piece of technology, the server. So over the next few minutes, we're going to pull back that digital curtain and really break down how it all works.
Okay, so before we can even get into what a server is, we've got to understand the world that they live in. Let's start with the absolute foundation of, well, pretty much everything we do online.
I mean, really think about it. You click on a website that's hosted halfway across the globe, and bam, it loads in seconds. You save a photo, and it's instantly available on your phone, your tablet, your laptop. How is that even possible? Well, the answer lies in this hidden world of machines that are all talking to each other.
And it all begins right here, with a network. The best way to think of it is like a digital highway system. But instead of cars, you've got packets of data just zipping between your computer, your phone, maybe even your printer. This highway is what lets all of our gadgets talk to each other. You're probably way more familiar with networks than you even realize. Your home Wi-Fi network? That's a perfect example of what we call a LAN, or a local area network. It's your own little private network that connects everything, from your computer to your smart TV, all under one roof. So, in a basic setup like this, you might have a couple of computers, and they're all plugged into a central box called a switch. Now, this switch, it's kind of like a traffic cop for your data. It makes absolutely sure that the information from your computer gets to the printer, and not to your TV by mistake.
So, where does the server fit into all of this? Well, a server is basically a super-powered, heavy-duty computer that lives on that network. Unlike your laptop that you shut down every night, this thing is built to run 24/7. Its entire job is to serve up data and services to all the other devices, which we call clients.
Now, for all these devices to talk to each other over the internet, every single one needs a unique address, kind of like a phone number. So, how many addresses do we have available? Get ready for this. It's 340 undecillion. That is a number with 36 zeros after it. It's so big, it's hard to even wrap your head around it. That absolutely mind-blowing number comes from the latest internet addressing system called IPv6. And why on earth do we need so many? Because of this thing called the Internet of Things. It's not just about computers anymore, right? Your smartwatch, your smart fridge, your car, everything needs to get online. And IPv6 makes sure there's a unique address for every last one of them. Okay, so we've got the physical machine, the server hardware. But a hunk of metal is just a hunk of metal, right? What actually brings it to life? Well, just like an orchestra needs a conductor, a server needs a special kind of software to tell it what to do. And that's the server's operating system.
You're not going to find the regular Windows 11 or Mac OS on a server. Nope. They run a very specialized network operating system, or NOS, like Windows Server 2025. This thing is the air traffic controller for the entire network, managing everything from who's allowed to log on to keeping everything secure.
And the tech here is always getting better. For years and years, computers used an old system called BIOS to start up. But now, all modern servers use something called UEFI. It's basically a mini OS that kicks in before the main one loads, and it is way faster and much more secure. And here's a huge reason why that switch to UEFI was so important. The old system, MBR, could only handle hard drives up to 2 terabytes in size. Sounds like a lot, right? Well, the new system, GPT, can handle drives up to 9.4 times zettabytes. To put that in perspective, 1 zettabyte is 1 trillion gigabytes. It's just a staggering leap forward. All right, so we've got the powerful hardware, we've got the smart operating system running it, but right now our server is kind of like a multi-talented employee just waiting for an assignment. We need to give it a specific job to do. So how does that work? A server can wear a whole bunch of different hats. We can set it up to be a file server to store documents, an email server to handle mail, or a database server. These different jobs are called server roles. And one of the most common roles out there is the web server, the machine responsible for dishing out websites. So how do you actually assign one of these roles? Well, in Windows Server, it's surprisingly simple. It's basically a wizard that walks you through it. You just tell it, hey, I want to add a web server, and the operating system handles all the heavy lifting in the background, installing everything you need. And here is the payoff. Once that web server role is installed, boom, the server is officially a web server. If you typed its IP address into a web browser, you'd see this default page. Just like that, we've given our server its job. It's now serving content to the network. And this is really where servers show their power.
You see, without a server, you have what's called a work group. Every computer is its own boss. Think of it like a bunch of independent contractors. But when you add a server, you can create a domain, which is more like a company with a central manager. This makes managing and securing large networks way, way easier.
Okay, now we're going to get to the technology that completely, and I mean completely, changed the game for servers and basically made the modern cloud possible. It's called virtualization, and it is one of the most important ideas in all of modern computing. Think about cloud giants like Amazon Web Services or Microsoft Azure. They have millions of customers, but they don't have millions of individual physical server machines. So how do they do it? How can one giant physical server run websites for thousands of different customers all at the same time?
The secret, the absolute magic trick, is virtualization. It's a way of using software to slice up one single powerful physical server into dozens or even hundreds of smaller virtual servers. We call these virtual machines, or VMs. The best analogy is an apartment building. You have one physical building, but inside you have all these separate apartments, each with its own tenant, completely isolated from the others.
And this isn't some add-on you have to buy. This technology is built right into modern server operating systems. In the Windows Server world, it's called Hyper-V. It's a hypervisor, which is just a fancy word for the software that creates and runs all those virtual machines. This, right here, is the absolute bedrock of the cloud.
So, we've gone on quite a journey, huh? From the basic cables of a network all the way to the mind-bending concept of virtualization. Now, let's tie it all together and see how this stuff actually powers our day-to-day digital world. So the next time you browse a website, send an email, or stream a movie, just remember what's happening behind the curtain. Those servers are the engines of the internet. The server OS is the driver at the wheel. The server roles are all the different destinations they can take you to. And virtualization, well, that's what turns a few country roads into a massive, global, interconnected highway system. It's incredible. In just a few short decades, we've gone from simple physical networks to a world that runs on these vast virtual clouds. The whole idea of what a server even is just keeps changing. So that leaves a pretty cool question, right? What's next? What will the server of the future even look like? Thanks for diving into this with me.